So this is a talk that I gave in New Zealand a couple of months ago at a conference called Paradigm Shift, which was run by a company called Product Spec over there. And so the focus of the talk is kind of on, say, like the major paradigms that I see as happening inside architecture. Just some background, if you don't know me, I'm a senior researcher at CASE, and my focus within CASE is kind of looking at future trends in the building industry and how we can keep CASE like ahead of what's happening inside the industry. So the talk's it's about paradigms and I guess the kind of genesis or like maybe some of the early examples of like a paradigm happening inside architectures. Obviously what was happening with Sketchpad back in the day. And I think that's like what's significant about this video is if you look back on it today, we can see things like the four-plane work view, which if you're working in Rhino today, in many ways Sketchpad's this kind of genesis of what we're doing today. And you can look back on Sketchpad today and see all of where we were and where we're going to be. But then at the same time, when you think about seeing Sketchpad back in like 1964, when this was invented, it's difficult at that time to really see what this could become. That back at that time, computers were really expensive. They were taking up entire rooms. It wasn't conceivable that someone would have a computer on their own desktop, or that you'd be able to carry a computer with you on the train today. And so when you were back there in 1964, it's not entirely apparent that something like Sketchpad is actually going to be a paradigm shift. You think that computers are going to be these intelligent things that are going to bring artificial intelligence. And it wasn't obvious that computers would be these things that were replicating like quite a menial task, which is drawing shapes on a board. So that's kind of, I guess, as an introduction, it's kind of just me couching what I'm about to tell you now, which is that much of these discussions about what the future is going to be and about like what the paradigms could be in architecture are inherently going to be problematic because we can't necessarily see what these technological changes are going to be. But with that kind of said, I think one of the major changes that we're seeing in the architectural industry and that we're seeing maybe in other industries as well is this kind of datafication of the architectural space. And in CASE we have this diagram. Will's got it on his t-shirt there, it's on our business cards, it's on the desktop, it's on everything we do. And it's this diagram that kind of affirms that we think that there's this relationship between buildings and data, and that increasingly we're going to think of buildings in terms of data. Already this is kind of happening. You'll see people talking about BIM, and so the BIM is like a database of building elements that become a building. But I think when we talk about BIM, often we're talking about data becoming building. And what's kind of significant about this relationship that CASE is proposing here is that there's a relationship not only for data producing the building, but that the building itself is somehow a data source, or that the building itself is somehow giving us feedback or information about what the built environment is. And so this presentation, I go through I will go through three major ideas or implications of this kind of relationship. The first one that I want to talk about is that it's the client who's really the benefactor of this relationship between data and architecture. And it's not so much something for the architect. Like the architect's maybe the person that's instigating it or pushing this forward, but it's the client who's the one that's like benefiting from it. And this is a diagram that I'm sure most of you are familiar with. You see it in almost every technology conference. And it's a graph of productivity in America. So 1964, when Sketchpad is introduced, pretty much the US economy's gone up in productivity 250%. And the reason that you see this graph a lot is that when you separate out the construction industry, you see the construction industry almost flattening out or declining in productivity over the last kind of 50 years. And people are like, they bring this up a lot because we're developing all this technology. We're developing technology for things like laser scanning. We're developing technology for augmented reality, or like 3D. Or like we're talking about building stuff on the moon, or we're stellar and we're putting like embedding electronics inside us, and we're thinking about what it means to even be a human anymore. And we're making these robots that build things on construction sites, and we're making these drones that are like carrying bricks onto the construction site. I'll just let this video play because it's pretty sweet. But yeah, so the drones. Yeah. So we have all this technology and we are producing all this technology, and the kind of paradox of this is that all these things that we're investing and that we're developing, that the productivity hasn't increased in the industry. And the kind of question here is why. And when you see this diagram presented in kind of technology conferences, you have this, there's a lot of people kind of talking about the sky falling and that none of this is positive, and that this is Alexander McQueen's dress 13, and that like this idea that technology is this really scary and like negative kind of effect inside the industry. The reason that I think that we're seeing a decline in productivity, or that productivity is flatlining, is that architects are essentially trading or passing off that benefit to their client. So because most of our fees are based on hourly rates, or even if we're doing it in another kind of accounting sense, it basically comes down to an hourly rate. If there's a technology that makes us better or faster or makes us better at making buildings, we're essentially passing that cost on because the market's so competitive. And that it's the client, the person that owns the building, the person that builds the building, the person that inhabits the building that is benefiting from this more than the architect. And this means, I think, that we should look at where the clients are going more so than where the architects are going, to get a sense of where the industry is going. And this is a company called Retail Next, and they do a lot of tracking about people's behaviours inside space, looking at things like where people are inside the space, looking at things like their emotional state of mind when they're trying to buy something and what they're doing when they're buying that. And this is to say that the clients of our buildings, the people that own buildings, are deeply interested in what happens inside these buildings, because there's like an economic imperative to them understanding what's happening inside there. At the Venice Biennale, Erin and I were there working on the Office US Pavilion. Rem Koolhaas, he lays out this kind of exhibition in the Venice Biennale, looking at 15 major architectural elements and looking at their progression from way in the past to like present day. And I think what's interesting about each of these elements is that if you take something like the fire, so the fire starts as this element in architecture that is maybe initially just in a pit or just inside a cave, and then slowly it becomes integrated into architecture. We produce things like the hearth and the fireplace, and then we develop all this kind of technology around like how we contain fire within the building, how we heat buildings. And what's curious about this kind of diagram of like where fire or where heat has entered into the built environment is this idea of the learning thermostat. And so Koolhaas, so if you haven't seen this before, this is Nest, and you change the temperature up and down, and it learns your behavior, and it adjusts the behavior inside, the temperature inside the room based on your behavior. And Koolhaas makes this point that every architectural element is about to associate itself or become a producer of data. And he's saying that things like whether it's a fireplace is something that's going to associate itself with data and producing data and using this intelligence, or whether it's something like a doorway, that every architectural element is going to have this capacity to produce and consume data. And there's obviously lots of examples of this. Yes, things like locks that know who you are. This is like one of my favorites. It's like a toothbrush, and it's connected by Bluetooth to your phone. And so it knows your brushing habits, and then it emails that to your dentist. Yeah. And this one, Whistle, they make like a fitness tracker for your dog, and you get like an app on your phone. You can see how active your dog is. And the point here is that like there's some like really fucking frivolous like examples of people just doing stupid shit with this, but if you can afford to do that, if you can afford to put a sensor inside your toothbrush, this thing that is really just a piece of plastic with bristles on it that you can put the sensor inside a toothbrush. If you can put a sensor inside your dog's collar, then every other element that we're producing inside the built environment is probably going to have these sensors as well. And just to take you through a case study of where this might lead us, I think Disney is one of the companies that's really on the forefront of this. You don't necessarily think of Disney as being architecturally like in the avant-garde or like architecturally sophisticated in what they're doing, but they're actually really, really good at what they do. So if you go to Disney today, you have the option of having this band sent to you. The band is personalized in color and it's given you a name. And it's really deliberate that they do that because they want you personally to wear this band. They tell you that the band is so that you can go to these, like, get on the ride, so you scan onto the ride and it's essentially a pass. But what Disney's actually doing with this band is that they have the ability to track where you are inside the space. So they're not looking just at like what rides you get on, they're looking at what you're purchasing when you have this band on, they're looking at how long you're spending in queues. They're looking at whether there's a correlation between something like you eating a piece of food, going on a really fast roller coaster, and then coming home quickly because you feel sick at the end of the day. And they're trying to optimize the time that you spend inside the park. That's like their main metric, because the longer that you spend inside the park, the more money that you spend. And the kind of net effect of this is that Disneyland becomes incredibly personal. It's kind of creepy to think about, but things like if you walk up to a character in Disneyland and you're wearing one of these bands, the character knows what your name is because it recognizes they have inside their like suit thing, a thing that tells you what their name is, what your name is, and they're able to greet you by name. And that Disneyland in this kind of weird way becomes more of a thing for you, and this space, rather than being some generic space that's intended for everyone, that it's able to adapt and morph itself to your kind of habits. So looking at like an example of where cases kind of worked in this space, this is a project that we did with MBBJ. MBBJ does like just really awesome kind of computational work, and they do a lot of, one of their major client types is lawyers. So this is kind of fit out for a law space, and they're looking here at the difference between an open plan office and then a closed, or this one's open plan and that one's closed. And they're looking at the difference in interaction as a result of that. And so what's happening inside this diagram is that an architect is beginning to see the effect of like the spatial layout and how this is impacting the building. They're able to see how this is impacting in habitation. And what you see with a firm like MBBJ, who's really sophisticated in how they're using these kind of technologies, is that they're beginning to sell their projects based on this. So that they're beginning to sell their projects not just based on the aesthetic look of it or on some kind of argument about philosophy and architecture, but they're beginning to sell it on the actual performance and the actual data that they can achieve as a result of their spatial layouts. The second kind of point that I want to make here is that data is as much about like the process of how we produce architecture as it is about the product of that. And I normally talk through two examples here, Sagrada Familia, which is a project that I work on in Spain, and the Dermoid. I'll skip over Sagrada Familia because we're recording this and they don't like me talking about it. But the Dermoid is this project that we did in Copenhagen a few years ago when I was doing my PhD. There's a big team of people in RMIT University from Australia and then from CETA in Copenhagen. And we're working on this project, the Dermoid. And this is the Dermoid installed. And so when you think about the design process, typically we have this kind of diagram that Patrick McLeamy made where we talk about these kind of definite stages of design, going from pre-design, kind of schematic design, into more detailed design, going through to construction. We talk about this diagram in the sense that the architect, as the project progresses, loses their authority to change the project or loses their kind of control of the project. So when the design is starting, the initial design that the architect is producing has a huge impact on the project. And then as things progress in the project, it becomes progressively more expensive to make a change to the project. An architect loses their ability to design through that. And so if you play this out in a project like the Dermoid, how you would typically discuss the narrative of producing that project would be that you start with like a napkin sketch. Maybe you went into some kind of analysis of like how that structure could be formed. In this case, using some of the principles from Sagrada Familia and Gaudi's work, looking at hanging chains to optimize the structure. Then you might look at like how you kind of go into refining that, creating patterns and stuff on the surface. Maybe structural analysis of what that element could be. Come up with documentation and produce the building. And the point of this kind of example is that the Dermoid doesn't really follow this typical narrative of a project. The starting point of the Dermoid wasn't a sketch, it was this concept of having some kind of curved surface and some kind of reciprocal truss system inside it. We started experimenting with what like these kind of reciprocal structures could be. Very early on in the project, we don't know things like where we're going to site the project, we don't know the cost of the project, we don't know really why, like the purpose of this, we're just experimenting with these kind of structural elements. We're doing things like producing details, looking at how the timber and the wood is behaving, its kind of material properties. We're trying to understand it and simulate it. And again, at this stage, we don't really understand or know the purpose of what this is going to be. We're looking at things like patterning structures. We're working in this kind of workshop space where we're working between physical models and digital models. Very early on in the process, we developed the structure of the beam, which was kind of necessary for us to do the kind of analysis. So we have this documentation of how to construct this object, but we don't actually know the size or the location of the object. We're doing things like structural tests on these beams to optimize them, to work out like what their structural potential is. Working out things like the curving properties of the timber. Doing things like looking at different patterning strategies on the surface. And so we end up with this parametric model where we have a whole lot of data going into one side of the model and getting out the other end some kind of construction strategy. And we're pushing the design from these kind of curves into these shapes, into these construction documents. And the point of this is that we end up with this really messy parametric model. The point of this is that a couple of days before construction had to start on the project, we produced this sketch, which is the actual, what we determined to be the shape and the function of the project. And we produced this sketch at the very end of the project. At a point in the project, we had the best understanding of what the implications of this were going to be. We understood when we produced this, how much this was going to cost. We understood when we produced this, how long it was going to take to mill. We understood when we produced this, the structural kind of implications of what is being designed here. And so by using this kind of data-rich process where data is going into the model, it's being transformed into this kind of piece of architecture, we're able to make these changes very late in the process. So typically it would be incredibly hard to change the topology of a project late in the project, but we're able to do it here because we've got all this embedded knowledge as part of the process. So this is the final Dermoid. And so rather than having this kind of process where the architect's losing control, we end up with this process where things become a lot more scrambled and a lot more iterative in the way that things are being produced. And so there's a kind of flexibility inherent within this use of data to produce this flexible kind of architecture. And I think that's a lot about the architect taking control of the process, but it's also about the architect being empowered to be a designer during that process. And so this is kind of one of the main diagrams for my PhD thesis, which argues for using data, using parametric modeling as a way to change our ability to impact the project, to make it more flexible and to make architects better at what they do. The third kind of implication I want to talk through here is that data is this opportunity to learn and to know about the project. So often when people are working in these data-rich environments at the moment, they're doing things like producing BIM models, and they're using that as a way of, that's the slide. They're producing a lot of data, they're producing emails, they're producing 2D documentation, it's information about the project. But really, what this data that we're producing is the potential for us to produce knowledge and wisdom about what we're doing. And so there's this huge collection of data that we're producing, and I think one of the things that we've really tried to do at CASE is work out what are the opportunities to develop some kind of insight or some kind of understanding from this data. This is another project that we did with MBBJ, and I think it kind of exemplifies what we were trying to do with this data. So MBBJ, they produce a lot of Revit models. They produce hundreds of Revit models of these different projects that they're working on. And MBBJ came to us with this kind of question, which was, we've got all this content that we've produced, we want to produce a content library, which is like quite a common thing for an architecture firm to want to do. And typically the way that you would produce a content library would be you would kind of go top down. So the most senior people would decide like what was going to be in the library, and they'd produce the best content, and then you would have some kind of librarian like going through and producing all this content, and you produce the model. What we said to MBBJ was that you've already produced all the content, you already have all the models. All that we need to do is find the best bits of what you've already done, surface those, and let those become the foundation for your library. So in some ways, all the data is already containing all the knowledge, we just have to find what that kind of knowledge is inside what you've produced. So we take 7 projects that really like exemplify MBBJ's different types of practices. There's 49 Revit models that we're analyzing in these. There's 20,000 families that we extract from these Revit models. And these families are used kind of 500,000 times throughout these different projects. And what we're able to do is we're able to graph these. This is the use of the families, the size of the family, so like how big the actual file size is and how many times that it's used. And so what we're looking for in this is like families that are below a certain size, and also families that are used a lot, because that's an indication of a family that's being valued within the firm, and also a family that's got these kind of parameters. And so we can start to identify these families and extract out of this. So this is specialty equipment. So starting with 4,000 different families that they were using inside their firm, and whittling that down into like 400 really, really good examples of content that we can then use to develop into the library. And so at the end of this, MBBJ gets kind of like a standards document based on like how they're actually producing, all these kind of norms that have formed within the data that they're producing, a library of the different elements. And so that's kind of, I've gone through this very quickly, I've taken out a couple of examples as well. That's kind of the main thesis of what I want to talk about here, that really we see buildings and architecture as being these two things that are like inherently interlinked, and that as a result of this, that I think what we're seeing in the architectural industry is firstly that clients are really pushing for this, they're pushing for data, they're pushing for architects to be able to talk about the kind of performative aspect of what they're producing. We're seeing architects using this data to make their process more flexible, to make the design process more designer-led. And we're also seeing clients using this data as a way to produce information, to produce knowledge, and to produce wisdom about what their firm is doing. So thank you all, and you can get back to hacking.